Good morning, P5 girls. I'm Mrs. Cheung. Today I'm going to continue the topic on volume and teach you how to calculate the volumes of cubes and cuboids. You will learn how to apply the calculation of volumes of cubes and cuboids to find the volumes of other objects too. Now, please get ready with your 5D textbook and a pencil. Turn your book to page 38, chapter 19. Do you still remember how to calculate the area of a square or rectangle? Finding the area of a square or rectangle is by multiplying the length of the sides. That is the measurement of the length times the measurement of the width. Learning the calculation of volume is similar. Now, let's take a look at John and Fanny's cuboids. John has made a cuboid using cubes. The volume of each cube is 1 cubic centimeter. How many cubes were used in making the cuboid? You can count the cubes, or you may also calculate it. The cuboid below is made up of 20 cubes, so its volume is 20 cubic centimeter. By calculation, you can multiply the size, that is 5 times 4, that is the 2D surface area of rectangle. And then you have to multiply the height as well, that is 1 centimeter. The volume of the 3D shapes of this cuboid would therefore be 5 times 4 times 1 equals to 20 cubic centimeter. Fanny stacked 3 cuboids like the one that John made and formed another cuboid. How many cubes were used to make this cuboid? By counting, 60 cubes were used. You may also use simpler method by calculation. There are 3 layers in the cuboid below. The number of cubes in each layer is 5 times 4, that is 20. But there are also altogether 3 layers. Therefore, the number of cubes used is 5 times 4 times 3 equals to 60. So its volume is 60 cubic centimeter. What is the relationship between the number of cubes on each side of the cuboid and its volume? I will pause for a few seconds and you can think about it. The answer is the volume of the cuboid form is equals to the product of the number of cubes in the 3 sides. Let's do the class study together. Take a look at the blue cuboid here. The volume of each cube is 1 cubic centimeter. The measurement of the first layer is 6 times 4. But there are 2 layers. Therefore, altogether the cube used is 6 times 4 times 2, which is equals to 48. There are altogether 48 cubes in the cuboid. So its volume is 48 cubic centimeter. The 3D shape below is a cuboid. We call its 3 sides that are perpendicular to each other its length, width, and height. What are the measurements of the 3 sides of this orange cuboid? The cuboid that Fanny stacked is 5 cm in length, 4 cm in width, and 3 cm in height. Its volume would therefore be 5 times 4 times 3 equals to 60. Its volume is 60 cubic centimeter. The standard formula of finding the volume of a cuboid is length times the width times the height. Now take a look at the cubes here. It is a 3D shape. The length and the width and the height are the same. The volume of the cube is equals to length times the width times the height. But the length of the three sides are the same. So the standard formula of the volume of a cube is length times the length times the length. You just only need to know the length of one side of the cube and you can find the volume of the whole cube. What is the volume of this purple cube? It is 4 times 4 times 4 equals to 64. The volume of this cube on the left is 64 cubic meter. We are on page 39, thinking station. How many cubic centimeter are there in a cubic meter? To calculate this question, we have to change the meter into centimeter. 1 meter is equals to 100 centimeter. Therefore, the side of this cube is 100 centimeter. The volume of this cube in centimeter would therefore be 100 times 100 times 100 centimeter. What is the answer for this question? I will pause for a few seconds. You have to do it on your own first. (100 times 100 times 100 is 1 million cubic centimeter. 1 follows by 6 zeros, that is 1 million. There are 1 million cubic centimeter in 1 cubic meter. Can you find the volume of each models below? Number 1. This is a cuboid. The formula for finding the volume of cuboid is length times the width times the height. That is 8 times 7 times 4. The answer is 224. And the volume of this cuboid is 224 cubic centimeter. Number 2. This yellow object is a cube. The formula for finding the volume of a cube is length times the length times the length. In fact, it is also length times width times height. But because it is a cube, the three measurement of the sides would be the same. Therefore, it is 3 times 3 times 3. And the answer is 27. So the volume of this cube is 27 cubic centimeter. Number 3. This model can be cut into a cube and a cuboid along the dotted line. The volume of cube A is 2 times 2 times 2, which is equals to 8. And the volume of cube A is 8 cubic centimeter. The volume of cuboid B is 8 times 6 times 4, which is equals to 192. Therefore, the volume of cuboid B is 192 cubic centimeter. Therefore, the volume of this purple object is by adding the volume of cube and the cuboid. That is 8 plus 192, which is equals to 200, yes. The volume of this model is 200 cubic centimeter. Number 4. There are 3 methods to calculate the volume of this model. Using John's method, the model is cut into 3 cuboids, cuboid D, E, and F. Find the volume of cuboid D first. That is 6 times 3 times 1.5, which is equals to 27. The volume of cuboid D is 27 cubic centimeter. Now find the volume of cuboid E. 4 times 2 times 1.5, which is equals to 12. The volume of cuboid E is 12 cubic centimeter. Cubot F is the same as cubot E. 4 times 2 times 1.5 equals to 12, and the volume of cubot F is 12 cubic centimeter. Adding the three cubots D, E, F together, the volume of the model is 27 plus 12 plus 12, which is equals to, yes, 51 cubic centimeter. And the volume of the model is 51 cubic centimeter. Now let's move on to Ben's method. He dissected the object differently into another three cubots G, H, and N. Cubot G is 7 times 2 times 1.5, which is equals to, yes, 21. The volume of cubot G is 21 cubic centimeter. Now find the volume of cubot H. Cubot H is 3 times 2 times 1.5, which is equals to 9. Therefore, the volume of cubot H is 9 cubic centimeter. Cubot N is the same as cubot G, that is 7 times 2 times 1.5, which is equals to 21. The volume of cubot N is 21 cubic centimeter. Adding the three cubots G, H, N together, that is 21 plus 9 plus 21 equals to 51. The volume of the model is 51 cubic centimeter. The answer is the same as John's method, right? Of course, it must be the same because they both are calculating the same object. The methods they used could be different, but the answer should be the same. Fanny used the third method. She fit in a small cubot to make the model into a big cubot. Then calculate the volume of the big cubot and subtract it by the volume of the small one, the cubot J. The volume of big cubot K is 7 times 6 times 1.5, which is equals to 63 cubic centimeter. The volume of cubot K is 63 cubic centimeter. The volume of the small cubot J is 4 times 2 times 1.5, which is equals to 12 cubic centimeter. And the volume of cubot J is 12 cubic centimeter. 63 minus 12 is equals to, yes, 51. The volume of the original model is 51 cubic centimeter. The answer is the same as John and Ben's method. Among the three, whose method is the best? Why? It seems that Fanny's method is simpler because it is the fastest and the most convenient.